note for you, we do find that these videos are often used over and over again. So thanks for taking the time to be here. The event today is focused on highlighting the accomplishments of the most recent United States Arctic Research Plan, which will conclude at the end of this year, 2021, and to emphasize the importance of collaboration between the United States and Greenland in Arctic science. And as we all know, many of us here are partners in this. Greenland is an invaluable partner for the United States and for IARPC, as well as important for global Arctic studies. So we're thrilled to be able to represent a small piece of US Arctic science to the audience today. And we've chosen to highlight 3 research projects which emphasize the importance of Greenland to the US research community. But to start off, I'm going to provide you with just a short introduction on what IARPC is and why it's valuable in the Arctic science community, the global Arctic science community, before we transition to the other speakers. Next slide, thank you. So IARPC, which is the Interagency Arctic Research Policy Committee, has recently produced a revised code of conduct that is used within our IARPC community, and we welcome input from our partner communities on this code of conduct. And we encourage all of our meeting participants to enter with an open mind and to be respectful of the diverse perspectives that are represented here today and always. I also want to take a moment to acknowledge that the circumpolar Arctic is the contemporary and ancestral home to many different indigenous peoples. As those who are working in or residing in the Arctic, we recognize these lands and waters as the mostly unceded traditional homelands of indigenous peoples. So wherever you may be viewing this webinar from, IARPC honors and recognizes the place-based knowledge of Arctic indigenous peoples, as well as non-Arctic indigenous peoples, and their ancestral and contemporary stewardship of their homelands. I welcome all of our webinar participants to do the same. It is the responsibility of each of us to learn, know, and gain a better understanding of the indigenous peoples and cultures with which we engage. For example, NSF is based in Alexandria, Virginia in the United States, and we acknowledge the Piscataway and Anacostan peoples whose traditional lands we are on. I share this to emphasize that it's very important that we not only acknowledge the land and peoples, but also actively work to incorporate indigenous voices into our work and recognize the history of colonization which has silenced those voices. I encourage everyone to seek greater understanding of and to enhance engagement, partnerships, and co-production of knowledge with indigenous peoples. Next slide, please. IARPC, as I said before, is the Interagency Arctic Research Policy Committee. And by bringing together leaders from 16 agencies, departments, and offices across the United States, federal government, we enhance research on environmental issues in the Arctic. IARPC was created by the US Congress in 1984 under the Arctic Research and Policy Act of 1984, or ARPA. And the act called for a comprehensive national policy focused on research needs and objectives in the Arctic. It established IARPC as well as the US Arctic Research Commission to help implement the act. And the director of the National Science Foundation serves as the chair to IARPC's principal agencies. Next slide. So one of the main purposes of IARPC is to bring together federal agencies to coordinate Arctic research and reduce duplication of efforts. And I know that many of these agencies, or at least several of these agencies, do conduct work in Greenland and partner with Greenland's research institutes. So as you can see here, these are the different government agencies that are involved and responsible for US investments in research in the Arctic. And these agencies work together to develop a new comprehensive Arctic research plan every 5 years. Next slide. The 5-year plan is created in consultation with the US Arctic Research Commission, the governor of the state of Alaska, residents of the Arctic, the private sector, and public interest groups. The plan identifies critical areas where US Arctic research supports US policy from community to global scales. The plan aims to advance knowledge and decision support for the challenges and opportunities that lie ahead. The current Arctic Research Plan was released in December 2016 and focused on the years 2017 through 2021. This plan will conclude at the end of this year, next month, and you will hear more in this webinar from speakers who conducted some of the research under the current plan. However, before we get to that, I would like to briefly touch on two aspects of the structure of IARPC before I provide a brief overview of the current plan successes. Next slide. The current and future Arctic research plan incorporate the principles for conducting research in the Arctic. And researchers working in the Arctic have a responsibility to respect local and indigenous cultures and knowledge and advance stewardship of the Arctic environment. The core principles were updated during this past 5-year cycle through extensive engagement with indigenous peoples in the US Arctic, as well as the extended Arctic science community. And those core principles are to be accountable, to establish effective communication, to respect indigenous knowledge and cultures, to build and sustain relationships, and to pursue responsible environmental stewardship. And I understand that Greenland is also embarking on the development of similar ethical guidelines for conducting research in Greenland. Next slide, please. The other aspect that I'll cover is IARPC collaborations. Well, the US government is a large part of the Interagency Arctic Research Policy Committee. Like the proverbial iceberg you see on the slide here, there's a lot more happening beneath the surface. We use the IARPC collaborations website to connect the federal part of IARPC to non-federal researchers and Arctic community members, not just in the United States, but across the world. You can think of the website as sort of a conference center, online forum, and event calendar all rolled into one. And IARPC collaborations is an important tool for IARPC because it allows sorry, I just saw a chat pop up there, but I think Liz is posting links for you in the chat box. IARPC collaborations is an important tool for IARPC because it allows communities of practice to come together across the Arctic and the world. Next slide. And the IARPC collaborations website is free, and it's open to anyone who can contribute regardless of their role in Arctic research or the country within which they're working. So we encourage everyone here, particularly our Greenland partners and all of our counterparts, to register for an account. During the past 5 years, the number of members within the IARPC Collaborations Forum grew by 200% to nearly 2,500 people. These members come from all over the Arctic research community. And as I said, it is open to international participants as well. And indeed, many of our members are not from the United States, but they include scientists and Arctic interested people from many countries in the circumpolar Arctic and across the globe. So if you're not already a member, please go to the website and register for an account and to join the community. Next slide, please. Okay. So the current 5-year plan, the one that's ending here in another month, has been centered around collaboration teams that were created to assist with the implementation of the current Arctic research plan. And those teams are organized around the 9 goals of the current plan, which you can see the names of the teams on this slide. Next slide. So in addition to those teams, IARPC Collaborations provides a space for researchers and other community members to organize around other important topics. So over the course of the past 5 years, we've had these additional self-forming teams created that focus on a single project or problem or serve as a general information sharing space. And so there's a long list of those self-forming teams here on this slide. And next slide, please, Max. So together, all of these teams work to implement the goals of the Arctic Research Plan. And the current plan, the 2017 to 2021 plan, was organized into the 9 goals, as we noted earlier, which sought to produce a better holistic understanding of the Arctic system. Those research goals are, number 1, enhance the understanding of health determinants and improve the well-being of Arctic residents. Number 2, advance process and system understanding of the changing Arctic atmospheric composition and dynamics and the resulting changes to surface energy budgets. Number 3, enhance understanding and improve predictions of the changing Arctic sea ice cover. Number 4, addresses marine ecosystems. Number 5, addresses glaciers, ice caps in the Greenland ice sheet. Number 6, focuses on permafrost. Number 7, it focuses on landscape scale understanding of the Arctic terrestrial and freshwater ecosystems. Number 8, focuses on strengthening coastal community resilience. And number 9, focuses on enhancing the framework for environmental intelligence. Next slide, please. So as we finish these last 2 months of this current plan, we're looking back over the achievements and accomplishments of all the people who have been engaged with IARPC. And as part of this, we've developed an end of plan report, which will be released in the coming months. That report overviews some of the advances IARPC has made toward better understanding our Arctic system. And the advances are grouped into 4 categories. Whoops, I think am I on the right slide? What's the next slide?
I think it's just lagging a little bit, Jen.
Okay, there we go. So into these 4 categories that you see on your screen. So improved collaborations, better observations, modeling to understand the Arctic, and application to human need. So now, before we move to our main speaker event, I would like to recognize 2 special guests in attendance today. So first, we're pleased to have Miss Katarina Vistendahl, sorry, I hadn't even practiced that earlier, Vistendahl, joining us today on behalf of the Greenlandic representation to the United States. So thank you very much for being here. And I believe, has Josephine joined us?
I don't think she's here yet.
I don't think she is. Okay, we were hoping that Dr. Josephine Nymund, chair of the Greenland Research Council, would also join us, and hopefully she will be here in a little bit. She had agreed to provide a short statement, so if she does come on, we'll have her do that, but I can talk about a few points on her slide here as well. I know that Greenland has produced a draft national strategy for research, and that's out for review right now. We're very excited about that and looking forward to what that means for the international communities working in Greenland. She was also hoping to highlight the joint workshop that was held in Nuuk in 2018, and that workshop focused on facilitating increased engagement between the research communities of Greenland and the United States. And then we have, as a result of that and several other efforts, we have a forthcoming publication entitled Bilateral Collaboration Between the Greenland and United States Research Communities from a Vision to Everyday Practice. And what's one of the very exciting things about that publication is that we have 3 Greenland co-authors on that publication that's coming out in a special issue of Polar Record, the Polar Record Journal on science diplomacy in the Arctic. And then there are 2 projects. These are NSF sponsored projects working in Greenland, but they're co-produced with Greenland's research community and Greenland researchers. And that is the Greenland Rising Project, which is studying coastline changes around Greenland. And then there is an innovations in energy technology in fishing communities. And that is also a co-produced project, which is working to bring renewable power to communities like Hanak. Next slide. Okay, so, and still no Josephine, right?
Correct.
Okay, all right. So now we'll move on to the rest of the event. So today you'll hear from a small subset of projects which are featured in the Arctic Research Plan. We have a lineup of 3 speakers whose work is deeply connected to Greenland. And they represent a swath of the diverse research that's accomplished through IARPC. So first we'll hear from Kaitlin Harbeck on advances in ISAT-2, followed by Dr. Igor Krupnik on Smithsonian's work. And then finally, Dr. von Walden will share his work on the Greenland ice sheet mass balance. So I will now turn it over to Max. Thank you.
Thank you very much, Dr. Mercer, and thank you for providing that introduction to IARPC. So our first speaker today is Kaitlin Harbeck. So Kaitlin Harbeck is a support scientist for the Cryosphere Sciences Program Office at NASA. She has a master's in earth science from The Ohio State University and a Bachelor of Science in Geography from Penn State University. For her thesis, Kaitlin studied and documented changes in Central East Greenland's marine terminating outlet glaciers using an array of different NASA remote sensing data products. Kaitlin previously worked in the ISAT-2 Project Science Office as the Data Products Manager for the ISAT-2 mission's Science Data Products at NASA Goddard Space Flight Center, and she joined NASA headquarters in January 2021. Thanks very much for being here today, Kaitlin.
Thanks, Max, and thanks everyone for hosting me today, and thanks for your interest in listening to me talk about ISAT-2. Let me just start my timer here. All right, so yeah, next slide, please. So yeah, like Max said, I'm going to give a little mission update on the ISAT-2 mission and talk about some exciting results that have come out over the last couple of years as they relate to Greenland. So yeah, I'm giving this presentation on behalf of the entire ISAT-2 science community. So thanks for featuring our mission today. Next slide, please. All right, so let me pull up my version of these slides here. It might be a little bit faster on my end. So ISAT-2 launched in 2018, September 2018, as NASA's next Earth-observing laser altimetry mission. It was the successor to the ISAT laser altimeter, which was in operations from 2003 to 2009. And then in between those two missions, ISAT and ISAT-2, NASA Earth Sciences sponsored an airborne sciences mission called Operation Icebridge to ensure that there was no measurement gap in between these two major satellite missions. So actually, Icebridge was still ongoing when this the current IARPC research plan was still in effect, and the ISAT-2 launched right smack in the middle of the current research plan. Measuring ice elevation was designated as a top priority in the 2007 National Academy Earth Science Decadal Survey. So we were fantastic to get a designated mission out of this. And like I said, launched successfully in September 2018. We've got more than 1 trillion measurements to date globally. We get up to 88 degrees north and south. So we have great dense coverage over the polar regions. And all of the data, as is all data for all NASA missions, is available for download by anyone at the National Snow and Ice Data Center's website. Next slide. So ISAT-2 has 4 primary mission objectives, and you see I've identified 2 here as being the most, probably the most outstanding for folks who are interested in Greenland science. And those are quantifying polar ice sheet contributions to current and recent sea level change, and linking those things to climate conditions, both globally and locally. And quantifying the regional signatures of ice sheet changes to assess different mechanisms that are driving those changes and to improve predictive ice sheet models. And so that's going to include quantifying regional evolution of ice sheet change, and specifically how those changes at outlet glaciers propagate inward and cause changes in the interior of the ice sheet. 2 of the other major mission objectives for ISAT-2 are related to sea ice thickness, sea ice freeboard, and vegetation canopy height. But for the purposes of this talk, I wanted to highlight a couple of really exciting ice sheet measurements that have been published over the last couple of years. Next slide, please. All right, so current status, ISAT-2 has been on orbit for a little over 1,000 days, and really exciting, last week we hit 1 trillion laser pulses, and this is spectacular. With the original ISAT mission, they only had 2 billion laser shots over the course of the entire 6-year mission. So this is really exciting. We've outpaced ISAT by quite a bit. So we don't just have one single laser beam emanating from ISAT-2. The instrument has 1 laser split into 6 beams arranged in pairs so that we can measure not only surface elevation change, but also a cross-track slope, which is very important in some regions in Greenland where we're measuring outlet glacier change. It has a roughly 11-meter footprint, and we're taking measurements every 70 centimeters along track. We have about 15 orbits per day, and we cover the globe roughly once every 91 days. So in Greenland, we've got a really nice seasonal repeat track of seasonal measurements that we can make. So all in all, the performance metrics of the satellite remain nominal and are within requirements. Even though ISAT-2 was originally only supposed to run for 3 years, we're rapidly approaching the end of our prime mission timeline, but that doesn't mean that ISAT-2 is going to stop taking data anytime soon, and the plan is to continue the mission moving forward over the coming years as the satellite and the instrument is continuing to be healthy. Next slide. So the bottom line, if you're interested in looking at ISAT-2 data, so our height accuracy is currently better than about 10 centimeters, depending on what the terrain you're looking at. Over steeper terrain, the height accuracy might not be as great. Horizontal location accuracy currently better than 5 meters. For specific targets that we're pointing at, the pointing control is about 45 meters. But for repeat ground tracking, which is how we're operating in Greenland, tracking over the same spot every 91 days, our pointing control is almost better than 10 meters in some places. So definitely meeting our mission requirements there in terms of measurement concept. All right, next slide, please. In the interest of time, I'm gonna skip this slide. Max, please. And I'm gonna skip this one too. Thanks. So let's get to some of the cool things that we've seen with ISAT-2. So shortly after the laser turned on in October 2018, ISAT-2 flew over the fjord in front of Jakobshavn Glacier in West Greenland and captured what I think is a perfect representation of the high accuracy, high precision measurements that are capable with this mission. So you can see here, we've got a map of all these little dots are individual photons that are returned to the Atlas laser telescope receiver. And the direction of flight is north to south. So the red arrow that you see there is going to be the progression of plots that we're going to see over the next three slides, excuse me. All right, next slide. So ISAT-2 and Atlas are capable of peering deep into these crevasses on the fringes of the ice sheet. And there's been a couple of fantastic papers that have come out that are detailing how to find and detect the bottom of these crevasses using high precision, high resolution ISAT-2 data. Next slide. ISAT-2 is capable of picking out these pretty massive icebergs and melange in the fjord in front of the glacier. And then next slide. And also capable of looking at some of the glacial tarns and seeing almost to the bottom of some of those tarns on the other side of the lake. Next slide. So probably the biggest result that has come out of Greenland science for ISAT-2 so far is comparing data measurements collected during the ISAT timeframe and the ISAT-2 timeframe. So covering about 18 years worth of measurements to get an estimation of mass change over both ice sheets during that time period. So focusing on Greenland, we estimate that Greenland lost about 200 gigatons of ice per year, and Antarctica lost about 118 gigatons of ice per year between 2003 and 2021. Which added about 14 millimeters of water to global sea level. So you can see here, not a whole lot of surprises in this plot. Most of the ice loss in Greenland is taking place at the margins with the big glaciers, Kangerlussuaq, Helheim, and Jakobshavn being the primary outlet areas of where the mass loss is occurring. A little bit of gain in the interior of the ice sheet, but definitely the losses are outweighing the gains tremendously on both ice sheets. If you're interested in reading a little bit more about this paper was published in Science last May, so I highly recommend that you check it out to read a little bit more about the process and what we did to get those measurements. Next slide. So some of the exciting ISAT-2 data products that are coming out that deal with glacier change in Greenland are the ATL11 data product and the ATL15 data product. ISAT-2's 91-day repeat cycle over the polar regions is allowing scientists to estimate seasonal height variability due to surface mass balance and ice dynamics as they change seasonally. So this is just an example plot of the ATL11 data product, which is currently available at the National Snow and Ice Data Center, showing quarterly height change variability in meters per year over the ice sheet. As you can see, most of the variability is occurring at the margins, with just a little bit of variability occurring on the interior. Next slide, please. All right, I'm going to wrap up quick here. And so one of the exciting products that has yet to come out, hopefully will be by the end of this year, is annual ice sheet elevation change. So with the 2.5 years of altimetry data that we have processed and released right now with ISAT-2, the mission is allowing us to make high precision estimates of height change rates for both Antarctica and Greenland. So this is just just a quick example of what that data product will look like when it comes out. Once again, no real surprises here, but the big thing is those high precision estimates of change rates for the ice sheet, allowing us to peer a little bit more closely than we have in the past with satellite and with airborne altimetry measurements. And I think that was my last slide. So thanks, Max. I'm happy to take questions during the panel.
Thank you so much, Kaitlin. I admire your dedication to staying on time. I appreciate that. And thank you so much for speaking here today. So as Kaitlin noted, we're going to save all questions until the Q&A panel at the end of all the speakers so that we can stay on schedule. So our next speaker is Dr. Igor Krupnik, who received his PhD in anthropology and cultural ecology at the Institute of Ethnography in Moscow, Russia in 1997. and has been active in Arctic socio-cultural and heritage research since the 1970s. Dr. Krupnik joined the Smithsonian National Museum of Natural History, Arctic Studies Center in 1991 after teaching at the University of Alaska Fairbanks and working for 14 years at the Institute of Ethnography, Russian Academy of Sciences. In 2005, he was appointed the National Museum of Natural History's curator of Arctic and Northern ethnology collections. He's conducted fieldwork in local communities in the Russian Arctic and in Alaska, especially in the northern Bering Sea, Bering Strait region. His main fields of interest include socio-cultural systems of northern indigenous people, community adaptation to rapid change, environmental knowledge, and heritage and knowledge preservation. Dr. Krupnik was recently awarded the Smithsonian Distinguished Scholar Award in 2019 and has received numerous additional awards, including the International Arctic Science Committee Medal in 2012. Thanks very much for being here, Dr. Krupnik.
Thank you, Max, for this lovely introduction. So can I see my first slide, please? It's kind of...
Max, can you toggle back and forth again?
Yeah.
Sorry for the delay. Thanks everybody for being patient on this. I think
Okay,
there's a lag.
Okay, here we go. Thank you. Thank you. So you're going to hear a very different type of science than the one before and probably the one after me. This is not a project. It's basically an overview of the activities related to Greenland, conducted by a special unit at the Smithsonian Institution National Museum of Natural History called the Arctic Studies Center, established in 1988, with its small office in DC and another office in Anchorage, Alaska. And the tasks that we have include research, outreach, collection, and education on Arctic or circumpolar indigenous people. We have very strong international connections, including a lot of kind of partners and collaborators in Greenland and in Denmark, as you will see from my slides. We have very active publication program. We also have activities that are specially focused on Greenland, such as a 3-day Greenland festival we host in spring 2005. Another Greenland event in 2015, and a few more that I will tell more later. Next slide, please. So first of all, about our collections. We have altogether about 1,000 objects from Greenland in the collections of ethnology collections of the Natural History Museum. This is a solid, but not, if I may say, spectacular collection. Several museums in Nuuk, in Copenhagen, even in New York, have more than us. The slide shows how they're distributed among different parts of Greenland, Kita, West Greenland, Tuna, East Greenland, Avanersuaq, North Greenland. And although collections are solid but not kind of outstanding, we have really some spectacular pieces in this collection, such as a substantial segment of the famous collection by Gustav Holm from Ammassalik that was exchanged back in the late 1800s with the University of Copenhagen, and for which we hosted 3 students from Elisimatu Sarfik, the University of Greenland, in 2018. We have a remarkable collection of tupilaks, the ivory carvings of supernatural figurines. That is probably the second largest in the world. And as an example, the second slide at the bottom is our small but very interesting educational collection from East Greenland that was donated to us a few years ago and represent the development of East Greenlandic culture during the World War II period and after that. Next slide, please. So perhaps the most important event related to Greenland is our project to celebrate the centennial of the 5th Thule expedition that started in 1921. The leader of the expedition was famous researcher and writer Knud Rasmussen. And it lasted almost 3 years, went all the way from Nuuk to Bering Strait, to Nome, Alaska, even to Siberia. Besides the mostly Danish scholarly team, the expedition included 6 Inuit participants from Avanarsuaq, from North Greenland, from the Thule area, and 1 Inuk, Jacob Olsen, who is pictured on the slide at the bottom, the right person at the first row. We just published, literally a month ago, we published a special issue of the Alaska Journal of Anthropology. I have the cover on the slide with the image, not very well seen, of Knud Rasmussen and the team actually on the glacier up of Kanak, not in Canada. It's them in the preparation for their march through the North American Arctic. Next, please. So the program was launched in 2018. You can see slides with the Greenlandic delegation visiting us at the Smithsonian. They're sitting in my office specifically in winter 2018. We held a symposium on the centennial of the 5th Thule expedition in Nome, Alaska in February 2019. The participants are shown in the slide at the bottom. And to the right are the Inuit participants at this session, including a person from Greenland, Marie Kleist, whom some of you from Greenland may know personally. Next slide, please. Here's Marie to the right, and the 6 Inuit participants of the Thule expedition, including 2 of them, Arnaron Guak and Kavigarsot Mitak, who went all the way with Rasmussen literally from Thule to the Bering Strait to Nome, Alaska, and then down to the United States. They've been to Washington, D.C. and traveled back to Copenhagen in 1924. So this project also included sharing historical knowledge in terms of historical photographs and documents and films with Inuit communities across the Arctic, including with people in Greenland, like in Marie's paper in the collection. Next, please. Cannot see it properly, this slide. Slow. Okay. So the previous one that also had a substantial Greenlandic component was a collection that we published in 2020 called Arctic Crashes, People and Animals in the Changing North. That was dedicated to the relations between naturally people, animals, and climate change in the Arctic. It has been a research project for a number of years, dedicated to another major event in the history of Arctic science, the seminal volume by Danish scholar Christian Vibe, Arctic Animals in Relation to Climatic Fluctuations. That was actually built on historical catch statistics from Greenland, primarily. The book we published included 2 chapters on Greenland, one written by Dr. Morten Melgaard, now a professor at Elisimoto Sarfik in Nuuk, and the other by Hunter Snyder, who did substantial research on Greenlandic fisheries in the past few years. Next, please. Yet another publication that we produced called Early Inuit Studies, Themes and Transitions, the history of the Inuit studies research from the 1850s to the 1980s. It was a 16-chapter volume with 6 chapters on Greenland, covering the life and contribution of such people like Heinrich Rink and Samuel Kleinschmidt, who was the author of the first Greenlandic dictionary. Of course, Knud Rasmussen and his colleagues, Kai Burkett Smith and Terkel Mathiasen, the beginning of Eskimology in Greenland with William Talbotser and Robert Peterson, who is featured on the photograph. Unfortunately, he passed away just a couple of weeks ago in Denmark. It has a chapter, my chapter, on the map of indigenous people of the Arctic and specifically on Greenland, produced by my late colleagues, Dr. Ernest Birch, with a list of traditional historic Greenlandic societies. And with Robert Peterson, we revisited Birch's map that he made also with Peterson back in 1982, and refreshed this information some 35 years later. Next, please. We do substantial dissemination and outreach programs related to Greenland. We had, as I said, special Greenland festivals, and you can see a dancing team from Umanak performing literally in the lobby of the Museum of Natural History where I work, or used to work before the COVID. We publish books related to Greenland, as you can see, and we continue this collaboration with Greenlandic communities, and we hope our links would be strengthened in the coming years as we all emerge from the COVID with a new energy to work. Thank you. I believe that's it for me.
Thank you so much, Dr. Krupnik, for that very interesting discussion. And also thank you to everybody for being patient as we are dealing with the technological issues of lagging slides. So our final speaker today is Dr. Von Walden. So Dr. Von Walden is a professor of civil and environmental engineering and a member of the Laboratory for Atmospheric Research at Washington State University. He received a BS in physics from Utah State University and an MS and PhD in geophysics from the University of Washington. Dr. Walden's research interests include polar meteorology and remote sensing of the polar atmosphere. He has conducted 8 field experiments in Antarctica and the Arctic, including a current deployment at Summit Station, Greenland, as part of NSF's Arctic Observing Network and navigating the new Arctic programs. Dr. Walden is currently serving on the Scientific Advisory Board for the German Trans-Regional Collaborative Research Center on Arctic Amplification. Thanks so much for being here, Dr. Walden.
Thanks, Max, and thanks everyone for joining today. What I'd like to do today is talk a little bit about atmospheric and climate research in Greenland and the contributions that have been made to the IARPC research plan, kind of in the context of how this type of research has been useful for understanding the mass loss that we're observing in Greenland. So next slide, please. So I just wanted to reiterate what the IARPC policy drivers and the critical areas of research have been: enhancing well-being, advancing stewardship, strengthening security. But really, what I'm talking about today is really scientific understanding, improving our scientific understanding of how the Arctic connects with the globe. And again, in the context of how important Greenland is to the global sea level rise. Next slide, please. Can you toggle that? There we go. So I just wanted to highlight that IARPC is a research coordination activity, and I wanted to give some examples of research that are related to Greenland. This is just a subset of what's going on in terms of IARPC, but some of the notable research efforts really show the breadth of what is going on. And so I'm just highlighting a couple of things, a couple of aircraft missions, NASA's Operation Icebridge and their Oceans Melting Greenland projects, which have been very important for understanding mass loss, as well as the satellite mission that Kaitlin talked about, the ISAT satellites, as well as the GRACE follow-on missions. And then also from the ground, the projects that have been sponsored by NSF, which I'll talk about in a minute, of which our project is one, and then also the seismic network, the GLISTEN project, that have all helped to understand how Greenland is changing. Next slide. So just as a way of motivation, what has been happening? This is really the INBI project has really used some of the stuff that some of the data that Kaitlin was talking about from ISAT. And this blue line shows the total ice or total mass change in gigatons. So this is the 200 gigatons per year that Kaitlin was mentioning. But what I want to draw your attention to is the two green lines, and that, or at least the thin blue and the green lines. And we can see that around 2010, the actual surface melting has become a greater mass loss than calving. And so in the last decade, there's been a lot of significant changes in Greenland, and indications that the surface melting is contributing to runoff that is now becoming a major contributor to sea level rise. And we can see on the right-hand side that the projections or the measurements that MB has put together are really on the outside of the limits. This is the highest melt scenario that is being predicted. And in fact, it matches pretty well with what the projections were for what we call the AR5 scenario. Next. So transitioning now to the atmospheric and climate research, I really wanted to emphasize that Greenland is a very unique and wonderful natural laboratory. It's obviously one of the two continental ice sheets along with Antarctica. The Greenland ice sheet influences weather and climate throughout the Arctic because it's a large topographic barrier with the highest point of Greenland reaching over 3,200 meters. Greenland is also being impacted greatly by global change, as I just showed with the mass loss. So it's very important to use Greenland as an indicator of Arctic change and actually as an indicator of global change. Next slide. And so where does our research fall? Really, the atmospheric and climate stuff really falls into goals 2 and 5 that Dr. Mercer was talking about. We're really trying to advance and understand how the Arctic is changing, both in terms of the atmospheric composition and dynamics, and how these relate to the surface energy budgets. Because the bottom line is, if the surface energy budget is changing, that is going to change, that could in fact create more melting, which contributes to sea level rise. Next slide. And so transitioning now to our particular project, we have, so our project that's been funded by NSF is called the Ice Caps Project. It stands for the Intercharacterization of Energy Clouds, Atmospheric State, and Precipitation at Summit. And we've deployed instruments, a very sophisticated suite of instruments at Summit in 2010. So we've been making measurements. We made measurements for over a decade to measure atmospheric and cloud properties as well as precipitation. And we did that through the use of regular weather balloon launches, as well as operating sophisticated equipment and instruments such as a cloud radar and LIDAR, as well as a host of spectrometers that use various portions of the electromagnetic spectrum to retrieve properties of the atmosphere. And so we were able to address in a series of about 40 publications over the last decade, what the characteristics of the near surface temperature inversion are, because that's so important for understanding what the surface energy budget is, and how temperature, humidity, and clouds affect that surface energy budget. And another thing that we looked at is how precipitation is affected at Summit by local and regional weather. All of these things, all of these process studies that we've been doing to understand how the atmosphere connects and is coupled to the surface is very important for to improve both weather and climate models. And so on the right-hand side, I have listed 2 publications. One was a publication in Nature, which highlighted a melt event, which I'll talk about in a minute. And then the other is an article from the Bulletin of the American Meteorological Society, which kind of gives an overview of our project. But you can follow the link below to get to a complete list of our publications. Next. So one of the things that we that was exciting was that we have been at Summit and have seen and measured recent melt events. Now, there have only been on the order of about 50 melt events at Summit Station in the past 10,000 years, but we've measured 3 different summers in the last decade of melt events, some occurring for multiple days in 2012, 2019, and 2021. These should be very rare events at Summit, but they aren't anymore. And what we're finding is that these melt events occur under a lot of different weather conditions. And you can see on 2 different days here, one was cloudy and one was clear. So that's one thing that we're finding, is that these melt events are quite varied. Next slide. This is a bit technical, but what I wanted to just show you is that this is a graph that shows kind of the rate of heat coming out of the snow. And we're seeing that in these melt events, at least in 2019, that the snowpack actually, that heat coming back up from the snowpack is actually an important contributor to the melt. So it's not just the atmosphere that's participating, it's actually the snowpack and heat transfer within the snowpack that's helping these melt events occur. So there's preconditioning, if you will, in the snowpack. Next slide. So just concluding, IARPC has provided essential interagency coordination for understanding a host of global change processes that are occurring in the Arctic and Greenland. Many agencies and researchers have contributed valuable knowledge to understanding these processes, especially those that affect the mass balance of the Greenland ice sheet. The Ice Caps project has used the incredible unique environment at Summit Station to increase our understanding of how the atmosphere impacts the surface energy and mass budgets. And we greatly appreciate being able to conduct this important research in the ancestral lands of Greenland. Next slide. Can you toggle that, please? So I just want to acknowledge all the other researchers who have participated to the report and the research plan, my co-PIs, and also my funding. And that's it. Thank you.
Thank you so much, Dr. Walden. And thank you again to all of our speakers for speaking here today. We're so grateful to have had you here and talk a little bit about your work as it relates to Greenland. So before we transition to the Q&A, I'd like to briefly turn the microphone back to Dr. Mercer to recognize Dr. Nyman.
Thank you, Max. So it looks like we've been joined by Dr. Josephine Nyman, who's a dear colleague of mine. So Josephine, if you're able, do you want to address the group here today? I think it's great that you're able to join us for this conversation. I did touch on the talking points when I gave my opening remarks earlier, so I did kind of go through them a little bit, but please feel free to talk about whatever you'd like to talk about. And it's nice to see you. I wish I was there to see you in person.
Well, thank you so much for organizing this event, and I have to apologize for the technical issues that I experienced here, not being able to attend from the beginning. But I just would like to address that the importance of the collaboration between the US and Greenland research communities, and that the increasing involvement of Greenland research institutions that we find is actually happening, and we appreciate very much. So as you may have mentioned, Jennifer, that we have developed a national research strategy now. It's in public hearing, and the work that is the basis of that is actually something that experience from the workshops and the collaboration that we have had over the years. So this is just as I and as we see it, just a natural way forward with working more together and developing projects together. So yeah, I think I can continuously speak on this, but I guess it will be fine just to be able to answer any questions that may be from anyone.
Great, thanks, Josephine, for being here. Back to you, Max.
Thanks so much, Dr. Mercer. So now we have just a little bit of time for any questions that you might have for any of our speakers. So I'll just highlight, if you have a question, please raise your hand and we'll call on you, and you can unmute yourself and ask your question, or you can also feel free to type your question into the chat box. And we can kick it off with a question for Dr. Mercer. Dr. Mercer, what is your vision for the future of US-Greenland connections in Arctic science from your position as the Arctic Science Section Head at NSF?
Thanks, Max. That's a big question. Well, but my vision, so I've been very involved in these efforts to increase collaboration between the US and Greenland research communities over the past 5 to 10 years. As Josephine mentioned, and as we mentioned, there is a workshop report that's available online. We have a forthcoming publication. And so since I've moved into this role as section head, now my role is changing to facilitate our entire team's efforts to improve and increase collaboration between the two research communities. And so Greenland has a full and vibrant research community on its own. And then there are also local communities, which of course are very interested in the research that's happening in their areas. And so I think for us, it's to continue along that path, to continue to build on the relationships that have been built between our governments and between our research communities, and continue to look toward co-produced collaborative projects, such as the ones I mentioned earlier, which are, we have two really fantastic examples. And those are just two examples. There are many more, but and as Josephine said, it seems like it's happening more and more where we have these collaborations. So true collaborations between the US and Greenland research communities. So in a nutshell, to continue what we're doing now and keep growing.
Thanks so much, Dr. Mercer. Dr. Niemann, not to put you on the spot, but do you have any thoughts about US-Greenland collaboration in the future, or any response to Dr. Mercer's comment?
Well, we are realizing in Greenland that we have been a relatively small science and research community, and compared to the amount of visiting scientists that we experience, we are still only as few as we are, but we are getting better at choosing our way of collaboration, and also choosing the projects that we want to invest in. And the way that we have been approached by several US research communities is something that we really appreciate, because it has been done in a way the last couple of years that we would like to see more of. So if things are moving in the same direction as they have been for the last couple of years, then there's a lot of work to do, and we are looking so much forward to continue this.
Great, thank you so much for that response. I have a question for any of our three presentation speakers as well. So we heard a lot today about both some of the natural sciences happening in Greenland and also some of the social sciences. And I'm curious if any of you could, pontificate or just think or comment on how we see the natural sciences and social sciences being connected, especially in Greenland, where it seems like so much of life is very deeply connected to the environment. And if you just have any thoughts about where we went when we were taking some of these research projects in the future to build better collaborations, better connections between different fields. I see Dr. Walden has your hand up.
Yeah, just really quickly, I think there's definitely a connection between the physical sciences and the social sciences as we move into really a transition period of global climate and local climate in Greenland. Obviously, the people in the northern regions of the planet are already experiencing global change and the ramifications and impacts of global climate change. So as we move into more and more change that's going to occur up there, it's going to be more and more important to understand what the impacts are on the well-being and of the residents of the Arctic and Greenland.
Thanks, Dr. Walden. Do any other speakers have any responses or thoughts to that question?
I may say a few words. Of course, the issue of relations between natural and social drivers to change is critically important to Greenland. And the book we did called Arctic Crashes, published last year, explored these connections. And again, I reiterate that it was inspired by a previous book 50 years prior, published by Christian Wiebe, using Greenlandic historical data to document environmental and human changes. On the other hand, there are certain social changes or cultural changes that are not necessarily driven by any natural phenomena, And we have to be careful, it is a connection, there's a very strong link, but certain social processes are going because of the societal factors, and we have to be careful about it. So culture change, language change, economic change, this is all driven by society per se. So that's my short footnote. So
Thank you, Dr. Krupnik. Any other thoughts?
I guess I'd just add really quick, sort of moving from my insular job as a data product manager for the ISAT-2 mission to then moving to headquarters, it's been really refreshing to see how NASA is trying to really integrate its remote sensing projects, its modeling efforts, its observing efforts to be more connected to the communities that are impacted by the phenomena that we're observing. So nothing specific, at least in terms of ice sheet measurements with ISAT-2, perhaps not necessarily primarily linked to those local populations, but our missions are observing other things that are very impactful to local populations, sea level rise, sea ice thickness and freeboard measurements, changing navigational paths through the Arctic, determining changes of the boreal forests in the northern parts of the world as well. So I don't know, that's kind of how I picture that, kind of how I frame that.
Thanks, Kaitlin. And thank you to all of our speakers. We're about out of time for questions. I'll give an opportunity for Dr. Mercer or Dr. Niemann to offer any closing thoughts before we wrap up.
I'll just say thank you and for the great conversation today. I think it's really important that we continue these engagements and in order to further the relationships. So thanks everyone for taking the time to be here. Josephine?
Yeah, this is a very good example of how if we spend more time together and actually start to talk more and cross-disciplinary, then new ideas and new ways of looking at things actually emerge. So I know that we are all extremely busy all the time, but we do need to take time to actually talk to other people in other disciplines in order for these things to develop in a more with a broader perspective. So and this is definitely one way of doing it.
Thank you very much. And thank you to all of our speakers who are here today. For the folks still on the call, I'll just wrap up by reminding you that we have the end of plan report, which features the projects that you heard about today, as well as a number of others that have taken place under the auspices of the 2017-2021 U.S. Arctic Research Plan, and we expect that this will be coming out in the next few months, so please stay tuned for that. And then I also want to just mention again that the next Arctic Research Plan, 2022-2026, is slated to be coming out soon, hopefully in December, and you can stay up to date by following this link here that's on the slide, or by going to iarpiccollaborations.org and learning more. And then finally, I'll just make one more plug for IARPC Collaborations. It's a great tool to do a lot of the things that we were just talking about in the Q&A session of connecting with folks in different disciplines and different regions. And so I encourage you, if you're not already a part of IARPC Collaborations, to please go to the website, check it out, register for an account, and it will provide, I think, a great opportunity for folks to engage with other members of the Arctic community and Arctic research community. So thank you again one last time to all of our speakers. We're really grateful for having you here today, and we really appreciate the time and all of your thoughts. Thank you.
Thanks, everybody.
Thanks, everyone.